Good evening and welcome to this webinar tonight with me, Mark Spevick, at Escape Studios on Advanced Maya. So last webinar a few weeks ago, we looked at Basic Maya, which was an introduction to the interface and how Maya works. There were some requests from some of the guys to go a bit deeper and a little bit more depth. So today I'm going to look at Maya in a bit more depth and show you some of the features that a TD may use. We're not talking about the effects or things like that. I'm talking about going under the hood and looking in the node editor and looking at the kind of relationships and more automated kind of things that you potentially could do in Maya. So let's start. It requires a little bit of an understanding of Maya. What I'm going to do is create a sphere and just remind you of how the geometry is created in Maya. If we look here, we have a sphere, as we know. If we bring up the outliner, we can see our sphere node here. Now, if you turn on in display here, shapes, you'll see the sphere is actually made of two nodes. If we bring up the attribute editor, we can see the various nodes, or these two nodes here. One of them is this transform node. That's the top one that you see when it's closed. And when it's open, you see this shape node here, the shape node. If you look at them, this here tells you the node type. So this top node is a transform node. This second node, this shape node, is actually a mesh node. Now in Maya, all objects have a transform node. If I select a camera, for example, you'll see that too has a transform node and a shape node. But this time the shape node is not a mesh, it's a camera. And it's got properties for a camera. Likewise, if we create a light, we'll see we also have a transform node and a shape node, but this shape node is a spotlight with the parameters for a light. So the one thing we can see here is that every node in Maya has a transform node. And the transform node simply is so that we can position our objects in the scene. It remembers the transforms, the X, the Y, the Z, and the rotations, and it has the pivot information. Now, that moves whatever is effectively a child underneath it. And it depends what you're dealing with. So in this case, it's a spotlight. In this case, it's a mesh. And in this case, it's a camera. So the shape node defines the actual object itself, whereas the transform node moves it around the scene. And everything has a transform node. It's important to understand these nodes and the type of attributes that you find on them, especially when you want to do some interesting things under the hood. Let's have a look under the hood. I'm going to select my sphere and I'm going to go Window, Node Editor. The Node Editor shows us how the nodes are laid out together. In fact, let me just change the display to be a little bit better. I'm going to right click here and go 3 panes split bottom. No, I don't want to do that. I want to do 3 panes split top. That's what we'll do. And we'll close down the outliner here. And we'll make it appear on this side instead. Oh, hello. Why has it appeared there as well? Close tab. There we go. And this bottom one, I'm going to make the node editor. There we go. This just makes a little bit more real estate on the screen. So we can see what's going on. Now, you'll see these two nodes are not connected because there's kind of a parent-child relationship going on. The transform node here moves the shape node. If I select both these nodes, yes, the node editor shows us the network of nodes in Maya. I'll just do a quick refresher of the interface here. Over here, we can turn this on and off. This will show us a display of all the nodes that we can add. You can also hit Tab, and if you know the name of the node, you can type it in here. So if I type polycube, you'll see I can choose a polycube node. Interestingly, the nodes here aren't all the nodes in Maya. These are mostly the shading and utility nodes, but everything in Maya is a node, and you can create them all with the Tab menu. Next, we've got these inputs here. These are very good. These show you what's plugged in, or what's plugged in and plugged out, or what the node is connected to. If you imagine the little icon, the square is a node, and this little triangle coming in shows you what's plugged in. So if I select the shape node and click this, it will show me what's connected to the left here. We can see it's this history node, the polysphere node. So this is a polysphere node that defines the sphere with an algorithm. And then that passes its information to the shape node, which is a polygon mesh, which is a mesh. That's a polygon object. And this draws that shape, whichever's plugged in. I mean, I can show you that here, because the output of this is driving the in mesh of this mesh node. Then, therefore, we get a sphere. If I was to type polycube, type that correctly, polycube, we'll see we have a polycube node. That also has an output, and if I switch the output, you'll see my mesh now draws a cube based on these parameters. So we can easily switch between the types just by plugging them in. This node is just a polygon node, a mesh node, and it draws whatever's plugged in. The good thing is if you disconnect the connection, it remembers the last thing that was plugged in. Because in Maya, when you say you delete history, all you're doing really is breaking this connection or deleting these original nodes, but this is remembering the position of all those points. So we can choose what we define. Now you'll notice I'm clicking on these little buttons at the side here. This opens up the nodes so you can see the various different displays there, whether they're complex or simple or not. And we have the same displays here in the interface, so we can toggle more than one node at the same time. We also have these little nodes here. Oh yeah, I was showing you these things, wasn't I? Let me plug that back in. Output to mesh. There we go, so we have our sphere. If I select this node again and I press this button, I'm only going to see what this node is plugged into. And it's plugged into the shading group, which tells it which shader to apply, in this case the default Lambert, and also the light linker, so we know which lights are going to light it. If I select him now and press the middle one, this is going to show me what's plugged in and out at the same time. And there I see the inputs and the outputs. If I actually select everything and show the inputs and outputs again, and then select everything and show the inputs and outputs again, I start to see how the whole scene is put together. So we have our sphere node that defines a sphere. It then passes that data to a shape node which draws it. This is connected to a shading group node. Now the shading group node is the glue of Maya that pulls everything together. This is a shading group, and to that is attached the shader. So we know which shader is affecting which geometry via the shading group. The shading group is also attached to the light linker, and so are the lights in your scene. So we can tell the shader which geometry and which lights are affecting it. And it's the shading group that pulls it all together. As you can see, that's connected to everything. Also, the shading group is connected to the render partition, which links to the render layers. So again, we can turn on and off what shading group is there, and therefore what geometry, shader, and lights we see from that shading group. Now, there's buttons here as well. This button here will simply clear the graph and remove the nodes. It doesn't delete them. Notice my sphere is still here. Let me pop some more nodes back in. And then we've got these nice nodes. These nodes help us manage the interface. For example, if I select this node here and I don't want it to see it, I can click the little minus and that will just remove it from the display. And I can remove any nodes I like here just to declutter the view. If you want to bring back nodes, let's get rid of the sphere. If I want to bring back a node, I can select the node here and click plus. Notice how it's brought back my transform and my shape. If I want the spotlight, I can click it and click plus, and it adds it to the current network. So we can manage what we see here quite easily. Now, if I move things around and they overlap or they just look ugly, we can select all the nodes and choose Layout Graph here, and it tries to lay out the nodes neatly for us. This will just toggle the size of the nodes, big or small. I quite like small ones, and I like to expand them up to use the connections that I want to. Sometimes if there's too many connections to deal with, but you know the one you want, for example, the colour, we can click on this little noggin when it's shut and we'll get a list. And we could choose, say, colour red or colour totally, and then we can plug that in somewhere else. So you don't necessarily need to open up a node to find the attribute. You could search this menu here. And if you can't find it there, you can click on Other, which brings up the connection window. And this shows us all the inputs, so you should be able to find it here, otherwise it won't exist. And then when you release, you have the noodle, which you can then connect to the other parameter that you want. So there's plenty of ways to edit within this menu. I'm going to select my sphere and just show the input-output connections, like this. Now we can do some other funky stuff. We don't have to, we can start to mess around with the way these are connected to build relationships. I'm going to create a locator, which I'll put over here. And I'm going to duplicate that. And I'm going to put that locator over the other side. Let's turn off the grid for a minute. So I have my sphere in 2 locators. Now I'm going to select all 3 of these. I'm going to clear the graph, and I'm going to click plus, which brings in those nodes. Now, I'm interested in only the transform node at the minute, not the shape node. So that's a shape node, that's a transform node, that's a transform node, that's a shape node. You can normally tell by name or by the icon. So that will be a shape, and that will be a transform. If you look, not only does it say shape, but you get the actual icon of the geometry there. Whereas on the transform nodes, there's just this little kind of box thing. I'm going to select these 3 guys and just click minus to tidy up the view. Now if I open up the locator, locator 1, that's this one on the left, you'll see it highlights. And we can look at the parameters here, or the attributes rather. And you'll see we've got things like translate, rotate, scale, which is this data here, translate, rotate, scale. And if you open up the little plus, you'll see we've got X, Y, and Z, so we can access the X, Y, and Z independently. If we keep that shut and use this outer one, we're using all 3 at the same time, and that's incidentally called a vector. If you want to get into the individual components of that vector, you can open it up and reach those numbers yourself. The different colors tell you the different data types. Green is a vector. This pinky color is a Boolean, which is just an on or off. These guys are arrays, which means a list of numbers. Now, I'm going to open up the P-sphere, and because this is a transform node, the same as the locator, we'll see it also has translate X, Y, and Z. Now, if I connect the translate of the locator to the translate of the sphere, you'll see the sphere jumps to the locator because now they both have the same numbers, 0.497, 0.497 in their translate. And you'll see that it's gone yellow, the one that is connected, the sphere. Now if I open up locator number 2 and plug that one in instead, you'll see he jumps to that position. So we can get this to switch between the 2 positions just by plugging them in. Now you can do this with constraints in Maya, but it's interesting to see how we can get into the node and start to manipulate this kind of data. Now we can actually, using other nodes, make this a bit more like a constraint. If I'm going to hit Tab and I'm going to type blend, and you'll see we've got this blend to attributes node. What this will do, it'll blend between 2 values. I have 2 values here. I have the position of locator 1 and the position of locator 2. Now to load them into the blend 2 attributes, you have to open it up and shut it and open it again. I think this is a bug. So that this input appears. Look, if I open it once, we don't see an input. If I open it twice, we see the attribute. And I have to open it a 3rd time to see the actual input. This is what we need. If I open it up, you'll see there's only one input. This will compare two attributes. Now, this is a thing of Maya. Often it shows you one plug, but when you plug one thing in, the next plug will appear automatically. It doesn't show them all at the beginning. So just be confident on plugging something in. So let's plug locator 1's translate in to the input. Let me close input and try it just straight to the input button. Okay, I'm going to blend the X position because that's what we've moved. So let's plug the X in. And I'm going to open up the locator 2 and plug its X position in. So on this blend, we've plugged the locator 1's X position and the locator 2's X position. Now if I plug, let me disconnect this from here. To disconnect, you can either select it, select it so it's yellow and hit delete, or you can click on the end here and just click away, and that will also break it. Or actually on the node itself, if you right click, you can say break connection, which will just disconnect it. I'm going to plug the X into the X. Now we won't see a change because this is already at locator 1, but the reason I want to use this, because on the blend we have here a blender amount. If we increase that blender amount, it should blend between the two inputs. Which it doesn't seem to be doing. Right, my mistake. I'm plugging in the input. I need to plug the output here into translate X. There we go. So as we move this between the values of 0 and 1, you'll see we blend between those two X positions. So a 0 is giving us the input 0 here, and a 1 is giving us input 1. And numbers larger than 1 keep multiplying that. As you see, it just carries on. So 0.5 is exactly halfway between the two. And to prove that, I can move this in X, and he stays always halfway. Again, you can do this with a point constraint, but we've just built our own point constraint. Now this doesn't work in Y, but that's easily fixed. All I need to do is copy paste this node, with duplicate rather. That's right, Maya doesn't copy and paste. And then in the inputs here, I'm going to now do this with Y. So input 1Y, input 2Y, and the output here now drives the new Y. To test that, it now moves in Y, but it doesn't move in Z. So we'll just have a third one of these to repeat that in Z. Let me just collapse these down. So again, Control D to duplicate. This time I'm not going to open it up. I'm going to pick Translate Y and plug that in on the noggin. Translate Z. And I'm going to click Other Translate Z. It's going to choose Other. We can go Input, Input 1. And then on here, we can choose Output and plug that into Translate Z. Now if I move this in Z, that didn't work. That's because the automatic, there you go, let's put it into the attribute binder. We wanted that in attribute 1. So maybe you do have to open it up, otherwise Maya doesn't automatically do it correctly for you. Now to test, we will move this in Z. That's right, that wants to be 0.5. There we go. So because we've got a 0.5 weight on all of these, we're getting half and half value between all of them. So our sphere will always stay halfway between these locators, no matter what dimension we move it in. This is basically a point constraint between two objects, but we've built it ourselves by wiring together the attributes here. And if we change the weighting, the blender, we can move it in one axis at a time, closer or further to another object, to the other object. Cool. So that's quite an interesting, fun thing to do. So we can see how we're pulling in attributes of some geometry. We're doing some operations to them, and then we're feeding some other geometry's attributes with the result. Now, you can go a little bit more powerful with this. We could write scripts. Obviously, scripting would be nice and quick to do stuff. But what we can do is, I want to show you some sort of logic that we can do in here. We can build conditions in. So what we can do is say, after a certain time, he'll jump, otherwise he won't. I'm going to do this with a cube this time, and my two locators. So I'm going to select my locators and my cube, and I'm going to click clear graph and then plus, just so I see my locators and my cube here. So shape, transform, shape, shape, transform, transform, shape. So I'm going to just hide these guys. And again, I've got my cube and my two locators. So this time I'm going to show you an interesting node. Rather than have a blend gives you this nice smooth blend with the weight, so it gradually moves between 2 points. We could do a switch, which is quite good for logic. So I've just got a quick question from Sajil. Just when connecting two nodes, is the wire used to show the attributes connected for both the nodes, or does this not happen anymore when connecting nodes? Oh, I see what you mean. When it's when the connection is there, can you hold your is that what you mean? When the connection is there, do you hold your cursor over it and it tells you the in and the outs? Yes, it is completely right. Let me just expand the input-output connections on this, and let's have a little looky. In here, if you hold your cursor over there, it does indeed. So just like old Maya, it tells you that the locator 1's translate X is connected to blend 2's attribute 1's input 0. So yes, you just have to hold your cursor over the connection and wait for the floating help to pop up. That should be on by default. I'm not sure if there's a menu option to turn it on, but in the docs, in the actual preferences themselves, you can turn on help balloons, which is what these hovering yellow things are. So I'm not sure if that preference actually turns those on or if they're on the whole time. So let's go into preferences. We go into help. We've got tooltips on. If I turn that off, will we still see it? Well, it might take a second to update. There you go, it's not updating now because I turned tooltips off. There we go. So if we go back to the preferences, in the help section, turn on tooltips here, hit save. Now if I have my cursor over there, that comes back again. Okay, so make sure you turn that button on, and then you should see it appearing on these guys. I'm not sure about the Hypershade. Sajid just said it may not be happening in the Hypershade here, but the Hypershade again in this version is in fact the node editor. So I would assume it should work here as well. But the Hypershade only shows us shading nodes really. It may not show us all the other funky stuff that we're doing. There we go. The node editor is the best thing to do, really. Now, where were we? We were selecting these two guys, clearing the graph, clicking plus, and we were getting rid of the shape nodes, which was those three. And then we can tidy up the graph with this button. So often in computers, to build behavior into stuff, you want to write a conditional statement saying if something does this, then do that. Or you want to compare two values and make some change or something based on that. So we can build some kind of logic in with nodes. Again, you can do this with coding. It's probably easier with Mel scripting or Python. But let's have a look at how we might do this with nodes. So there's a good node now. If we hit tab and type choice, this node will let us make a choice between two inputs. Again, it's one of those you have to click a few times before you see the input on the left here. Now, we can put any input we like in. I'm going to put my actual whole position in this time. So translate onto input 1, and then that's locator 2. Actually, I should have done locator 1 first. So let's put locators 1 on input 0, and locator 2's translate on input 1. Notice I'm not just doing the X, Y, and Z separately, I'm doing all three at once. Now it's got a selector here. Let's plug the output of this into the position of the cube. Instantly you see it jumps to locator 1. Because on the choice here we have a selector. 0 means we're going to go to 0 input here. 1 means we'll go to 1 input. And if I plug something else in, I could press 2 and that would go to the next input and so on. Just to demonstrate that, let's duplicate this little node here. And we get locator 3. Let's move locator 3 over here. And again, I can grab his translate and pop that into input number 2. So it's the third input. So if I put 2 here, that'll be the third input. He jumps to the third locator. So by changing the number here, I can get him to jump between the different inputs 0, 1, and 2. Which is kind of cool. Not as smooth as the blend. It does literally jump between one input state and another, rather than a blend. Which is quite fun. We can actually automate this. We could put, let's forget the third input for the minute. Let me just delete that one. I've got 2 positions I want him to be in. Now I have to keep coming in here and setting 0 and 1. It's a bit awkward. It'd be good to have a little button that we could just click and he would jump between the 2 positions. So again, let's look at how we might manage that. I'm going to select this node. Now I'm going to add my own attribute, just for fun. Okay, and I'm going to add it to this node. Now most nodes in Maya, you'll see at the bottom, have an extra attributes tab. And we can add our own parameters here and then write a simple expression to link them in, or even connect them up in the connection editor. So what I want to do is create my own connection to control this button, just to show you how you might do that. But I'm going to convert this from a number to an actual checkbox. So I just click it on and off and he'll jump between the 2 positions. So first of all, we want to add a parameter to this node. So I must select this node. Just because the node is selected here in the attribute editor does not mean it's selected. Look, I'll select the pCube node, but then I can choose other nodes here. If you look, pCube is still selected. What I have to do is hit select here, and as soon as I do, you'll see this is no longer selected. Okay, so if I make sure my choice node is selected here and click select at the bottom of the attribute editor, I can guarantee that that node is selected. Now I want to add an attribute here to change this number. So we go to the attributes menu and we choose add attributes. Here we can change the data type. If I leave it on float, it's going to be a slider. I want this to be a Boolean, which is a switch either on or off. So let's call this switch position. When you hit OK, you'll see you now get a little button. Now that will return a 0 and a 1 when it's ticked and a 0 when it's off. So I'm going to write an expression for selector here. So if you select the word selector, right click and choose create new expression, you'll see it listed there. I'm just going to cut and paste that into the expression editor. And I can simply say this is equal to, and you'll see we called it switch position. When we hit create, you'll see Maya actually fills out this beginning bit, which is the name of the node. That's because Maya knew we were on that node. Technically speaking, you should always write it as the name of the node, dot, and then the name of the attribute that you want. That's connected it for us. And you'll see when I click on switch, it changes between 0 and 1. And now I have a button to jump in between the 2 spots. If I go back to my sphere here, and I click on input-output connections here, I'll see all the blends that we did. And we've got this blend weight. Now I'd like to link all these guys together. And again, I would like to do it with a slider on this sphere. Now when you select the sphere in the viewport here, your chances are it'll take you to either the transform or the shape node. Let's do this with the transform node. On the transform node, I'm going to hit select to make sure this node is selected. And I'm going to go add attributes, and I'm going to call this weights, or let's call this blend position, blend pos, because it's easier to type. And this time I want this to be a float, so I get a slider. And I want the minimum to be 0 and the maximum to be 1, so it will limit it between those two, and the default to be 0.5, so it'll start off halfway between the two. Now you'll see I have a slider that goes from 0 to 1, and it came in at the default of 0.5. Don't think I can revert it to defaults, can I? No. Let's put 0.5 in. If you try and put numbers higher than 1, it won't let you, because we set that as the minimum and maximum. We only can blend between 0 and 1, which is good. So this attribute name would be the name of the node, in this case psphere1.blendPos. So now that we know that, we can write the expression in this blend value, and in this one, and in this one. Well, instead of writing an expression, actually, we could select the transform node here, and because we made our own expression, it should appear there. There we go, blend position. So you don't have to write any expressions. So I can grab this blend position. In fact, let me open up one of these so I can see the blender. There it is, attribute blender. So let's plug that into attribute blender. There we go. And the same with this guy. Let me just move some of these out of the way. It's getting a bit messy. That's number 3, that's number 2. So again, this guy's attribute blender plugged into the blend position, or rather the blend position plugged into the attribute blender. It's looping back, isn't it? This is plugged into that, which is then driving something on this. So now if I change this, I can get it to blend between both locators. Cool. I've got a question from VJ. When I apply the texturing to OBJ file, I can't see the texture on the object. When you apply a texture, you must make sure you go to the lighting, where is it, shading menu, and turn on smooth shade all. And then you need to turn on hardware texturing, which is the same as hitting 6 on the keyboard. Okay, if I apply a texture to this, let's assign a new Lambert, and I give it a color. Let's put a checkerboard on there. There we go. Let's make that yellow, and that red. Nice and funky. So the different display modes are 4, which is wireframe, 5, which is shaded, 6, which is shaded and textured. So that's this hardware texturing on. But if I press 5, you'll see it's not on. That's also, there's buttons here that can do it. So these buttons, this will show texturing. This will show wireframe on the shaded. And this will show wireframe or shaded. Or 4, 5, 6, and 7 actually shows it lit. We don't have lights in the scene, so it's black. And that's this button here. So we've put on this sphere a weight that we can move between the 2 points and get it either closer to that one, or we can get it closer to this one. So we're seeing how power users might build a rig where they put their own attributes here and then build these kind of relationships to control interesting stuff. And they just give the animator simple controls that they can pull around to create some complex behavior. There's another interesting node that I like to play with, and I'll make this the last one and then we'll have some questions. So I'm going to clear the node view down here. And what I'm going to do is I'm going to draw a curve. Just draw a curve. Now, if you hit Tab to get your nodes and type info, there's quite a few info nodes here. For example, we have a curve info node. We have a surface info node. If you look at these nodes, or rather look at their outputs, you'll see they can give us data. We can find out for surfaces things about the control points and the knots and things like that. Whereas with a curve, we can find out the length of the curve and also the where the points are. I'm going to mess with a curve to show you how you might use some of these info nodes. Now, we don't want the transform node this time. We want the shape node, because the shape node is the thing that defines actually the information of the curve itself. And the curve info will give us that. Now, it's one of these again. Look, I have to click it 3 times to get the little button on the left. So we plug a curve in here, and then we can access data about the curve on the side, on this side. So you plug in local. Now this knows about this particular curve. So what can we do? Well, let's create a sphere again, because I like spheres. There he is. And I'm going to just hide these 2 nodes because I want his transform node, this. Just to show you that in the curve info node, if we open up control points, this is again an annoying thing. It's only showing us control point 0, which is the first control point on the curve. To remind yourself of Maya curves, let's just make this big. The curves always start with the little hollow block. That's where you drew it from. And the second one in is always the direction. This is a U curve. So this will be point 0. Now, I'm going to plug in point 0, which will be that one at the end. Now, when I do, I'll see the list of other points magically appear. It's a quirk of Maya. So look, if I get point 0, we can see point 0 is driving the translate of the sphere here. Let's move the CV around instead. See, if I move the CV around, the sphere goes with it. There we go. Now when I move the curve, no, the sphere should go with it. There you go. When you actually move the real CV, it does go with it. We can also do the opposite kind of thing. If we look here on the actual curve shape, you'll see we've got control points in. And there's control point 0 in, if you like. So if I'm going to create a box, let's just curve snap the box to the end and make this big. So I'm going to get the transform of this box here, the translate X to control point 0. So now my box is controlling that CV, which is then controlling that sphere. Here's an interesting thing about curves. If you select a curve and go to the curve menu, you can lock its length. This creates a new attribute here. And what that does is it makes the curve not stretch. And look, as a result, you can kind of pull the curve around like a rope. Swishy, swishy. Which is kind of cool. A bit like a curve constraint in the hair tools. But again, we've built our own. We can use this curve info. Am I getting my list of points yet? No. Why is that not doing them all? There we go. So if I shut it open it a few times, now it's showing me the list of all the control points on this curve. So 1 at the end would be 9, and 4 would be in the middle. Let's create another sphere. I'm just going to duplicate this second sphere. And I'm going to get control point 0 here to control the second sphere's translate. So that's the last CV. There we go, at the very end of the curve. Or I could get the one in the middle of the curve. As you see, he snaps to the middle of the curve. Again, if I pull my box now, he's stuck to the middle of the curve because that position is driving his translate position. Kind of an interesting effect. So all I'm doing is animating the cube, and I've only got this snaky-like effect. So again, if I was to duplicate that sphere again and get another control point here to drive him, There we go, got another sphere on the end. And we could build a very interesting kind of animation going there. So we're building all these relationships between objects by wiring together nodes down in the node editor here, or rather up in the node editor. As you can see, we've got some very interesting things going on. We click Layout Graph. There we go. So things like our curve driving this curve info, which is then driving the position of those points. Or in this case, we have the locator and the sphere. We have a blend amount for the sphere, which is going to allow us to move it between two locators. So if we move those around, that sphere is going to hover between them. And then on our box, I can't remember where I put the switcher, that's it on the choice. We had a look how we could put a logic statement to switch between, and then create a switch to switch between those 2 points. Cool. Now I'm going to do one last little thing around this choice fellow. We've had it connected to this switch before, so the little box jumps between the switches. We'll just hide all this stuff so it's not confusing. So yeah, we've got our little box here, and he will jump between those based on the choice that we make here with this choice node. Now that's because we connected this selector to that switch using an expression, if you remember, saying that it's equal to the switch position. Now we can stop an expression just by putting 2 forward slashes. This is commenting it out, and you'll see it's no longer connected. If I turn the switch, it has no effect. We're going to control this in a slightly different way. There's another interesting node here, and it's called float logic. This will allow us to compare two numbers. I'm going to put the out boolean. Notice there's an out boolean. It's either an on or off, which suits our switch position here, our selector. Let's plug that into selector. Switch position was the one we created. Selector is the number here. We only want it to go between 0 and 1, so this is fine. So how does this logic work? Well, we can compare two numbers. So at the moment, it's saying if it's true, if the value is true, we'll get a 1. If it's false, we'll get a 0. So at the moment, it's true, so it's gone to input 2. That's because we're saying 1 is equal to, this is the operation, 1. If I say 1 is equal to 0.5, that's false. It jumps to the other one. But as soon as this condition is true, it works. So look, I could say something that 1, it's A, is larger than B. That's true. It jumps to the second one. Whereas if I say A is smaller than B, that's false, and it goes to the other one. So we could say greater than or less than, less than or equal to, greater than or equal to, is equal to, not equal to. See, 1 is false, 1 is true, 1 is false, anything else is true. So you could do something like, let's pop another square in, another cube in. There's his transform node. It's all getting a bit confusing. There's the float logic. Let me just view these two on their own. So I'm going to plug in his scale x to float A. And basically, I'm going to say if his scale x is larger than 3. So this cube is not larger than 3. So the other one's at position 0. So as soon as that gets larger than 3, you'll see he jumps to the other place, based on our condition there in the logic here. So this is connected to the scale in x. So scale in x has to be larger than 3 for this to be true, and jump to the other one. So look, there you go, it's 2.8. Let's just see that happening. So as soon as I just increase the scale over 3, pop, you see it jumps. So we can automate and build behavior, switches that we've seen. We can blend between attributes. We can get funky stuff to follow curves. can do all sorts of very interesting 2D-like things where you build relationships into the scene, relationships between objects, conditions that if certain parts of the animation or certain times things happen or they don't happen. You can connect up curves in an interesting manner. Even use this as sort of as an animation type thing or modeling. You know, it's quite nice to place out curves with that lock length. So there you go. That's it for today. We've really gone through quite a lot of interesting different concepts or ways of using Maya as opposed to the modeling. I've got a couple of other questions here. How can I render 96 frames in a second? If you go to your preferences, that's from Avinash. If you go to preferences, and you go to animation, is it, or settings, here we go. Here we have a time, and you should be able to up this down to 96. Well, that's the time on the timeliner. Is there not a custom one here? That's interesting. There's no custom one. You can get quite close to it here. Now, if you want to render it at the same frame rate, when you open this up, your timeline doesn't have to be the frame rate you render at. Let's change this to a sequence. So look, you could, you want to actually render at 96 frames in a second, right? Well, this is going to give you one frame. That's going to give you 10 frames. So if I do this, for the timing, I'll get double the number of frames. So what you need to do is, work out the FPS that you need here. So I think Maya only does between 80 and 100, so you can get close to it with that, I think. Is it really necessary to make all the polygons quad in high poly? It depends what you're doing. The reason we say quads, or at least we teach our students to use quads, is because of this, if you're going to subdivide the mesh. The subdivision algorithm requires particular geometry, otherwise it doesn't work. So then you would need quads, especially if you're deforming it. But if you're not using the subdivision algorithm and you don't see any artifacts in shading, then anything is kind of convenient. So yeah, quads are only really essential if you are going to use the smoothing algorithm. Excuse me. One more question. So why is the transform node is not connected to the shape node on a node editor? Because they're not connected, basically. There is no data that follows one to the other. The way it kind of works is the transform node is a transform matrix. And at the very end of the process, it multiplies that with all the point positions of your geometry to find the new position. So they don't need to be connected. There's no data actually passing through a little branch, if you like. You know, whereas here we're actually plugging one value into another value on the node, whereas the transform is applying its transform matrix at render time, so you can see that new position change, if that kind of makes sense. Avinash again, how to render those 96 frames. If you have to create, so if that 96 frames per second, is that because if you filmed it over sped, right, the best thing to do is to bring it back to, so it's playing in real time, not slow-mo, and then work on it as if it's real time and then retime your simulation later. It's very hard to do simulations or smoke not at real time. So always work in real time and then retime it for slow-mo later. So if your footage has been slowed down, speed it up to work in real time and then slow down the simulation cache to do the slow-mo again. Otherwise, it's a nightmare to control. Okay, last question from Sajil. Is there a create window? Oh yes, good. There's a create pref window, wind UI.mel. You can change the FPS in there. So there's a mel script you can dive down into that may help you. Cool. Oh, last question. I want the mesh to flow with the curve. Can you show me? Probably not easily, but if you want a mesh to be flowing with a curve, in the animation tools, we have animated sweep or animated snapshot. These guys will get your guys to follow a trail, follow a curve. They'll copy points along a curve or deform them along a curve. So that's it for today. Thank you guys for listening to this Escape webinar of slightly more advanced ways of using Maya. We'll be planning to do maybe a couple more of these in the very near future, some more advanced stuff from Maya. It's always good to be in contact, so if anybody's enjoyed this today, please drop us a mail of any content you would like to see in future webinars, particularly from Maya. And I'm hoping to also do a couple of introductory ones to Houdini as well, if people are interested. So please feedback to us if you enjoyed today's session and if you what content you would like to see in future webinars. So cheers guys, thanks again, and enjoy the rest of the week.